Have you ever been studying for a networking exam or maybe trying to figure out why your connection is so slow and you come across terms like collisions and late collisions? Yeah, they sound pretty bad, but what do they actually mean? Are they normal? Are they a sign that your network is about to explode? All right, let's jump in and get you a straight answer once and for all. This whole explainer was actually kicked off by the very real frustration of a student on Reddit, Draco, who was just trying to nail down these concepts for a test. And you can just feel it in their post, right? They just wanted a simple answer to what feels like a simple question. So today, we're going to deliver that answer. So to really solve this mystery, we got to go back to square one. How do two gadgets even talk to each other over a single wire? Turns out there are really only two ways they can do it. And a super simple analogy makes it all click. I love this analogy. Think of a half-duplex network like you're using walkie-talkies. Only one person can talk at a time. If you both try to talk, all you get is that awful static. That's kind of how old networks with hubs worked. Full duplex, though, that's like a telephone call. You can both talk, you can both listen, all at the same time, no problem. And that's how pretty much all modern switched networks operate. So the big question is always, are my devices acting like walkie-talkies or are they acting like telephones? Okay, so what if we are in that old-school walkie-talkie world, that half-duplex network? What happens when two devices do try to talk at the same time? Well, you get a collision. But, and this is the really surprising part, in this one specific scenario, collisions aren't just a possibility, they're actually an expected, totally managed part of how the whole system works. The system for managing all this chaos is called CSMA/CD. It sounds super technical, I know, but it's really just a set of polite conversational rules. Carrier sense multiple access just means everyone can use the line, and they listen first to see if it's free. And the collision detection part, that's the plan for what to do when two devices inevitably talk over each other. They detect the garbled mess, they stop talking, they wait a totally random amount of time, and then they try again. It's surprisingly civil, really. And here's what that process kind of looks like. A device gets its data ready, it listens to the wire to see if anyone else is talking, and if it's all clear, it starts sending. But check this out. There's a question it's always asking. Collision detected? If the answer is yes, it doesn't freak out. It just kicks off a little back-off algorithm, waits a moment, and then starts the whole polite process all over again. It's a built-in recovery plan. So let me be really clear about this. If you're looking at an old network that uses hubs, and you see that collisions counter ticking up, that doesn't necessarily mean anything's broken. It just means that the CSMA/CD process is doing its job exactly the way it was designed to. It's just normal chatter on a busy line. All right, so if some collisions are normal, that must mean there are others that aren't. And that brings us to the real villain of our story today, the late collision. Understanding why a collision being late is such a huge problem, well, that's the key to everything. It really all comes down to timing. The official Ethernet standard has these super specific rules about when a collision is allowed to happen for that polite CSMA/CD recovery thing to work. If a collision happens outside of that very specific window of time, the whole system just falls apart. And that window of time, it's defined by this magic number, 64 bytes. That's the smallest possible size for a legal Ethernet frame. And the reason it's that size is to guarantee that if a collision happens, no matter where on the cable it is, the sender is definitely still transmitting when the bad news about that collision gets back to it. And that right there gives us our definition. A late collision is any collision that happens after the sending device has already sent those first 64 bytes. See, by that point, the sender has basically planted its flag and claimed the wire. It assumes it has seized control, and nobody else should be trying to talk. A collision this late in the game is a major foul. It's a violation of the rules. So why is this such a big deal? Well, when a normal collision happens, the network card, the NIC, handles it on its own instantly. It stops, backs off, retransmits, all in a fraction of a second. But with a late collision, the NIC basically throws its hands up and goes, nope, not my problem. It's too late for that quick hardware fix. The problem gets passed way up the chain to higher-level protocols like TCP, and the recovery process is something like 10 to 100 times slower. This is what makes a network grind to a painful, absolute crawl. Okay, so if a late collision is a sign that something is seriously, fundamentally wrong, what could actually cause it? We're now officially in the detective phase, and it turns out there are really two main suspects we need to investigate for this particular network crime. And here they are, our prime suspects. Suspect number one, and honestly, the one you'll see 99% of the time, is a duplex mismatch. This is when one end of the cable thinks it's on a telephone call while the other end thinks it's using a walkie-talkie. Suspect number two is a lot less common, but simpler. The Ethernet cable is just physically too long. Let's dig into that duplex mismatch, because it's the big one. This almost always comes down to a simple misconfiguration. Picture this. A network admin manually sets a switch port to full duplex. Then you plug in a computer that's set to auto-negotiate. Well, the negotiation fails, and the computer's only choice, by rule, is to fall back to half duplex. Now you've got total chaos. The full duplex side thinks it can talk whenever it wants, even while it's listening. The half duplex side sees that incoming traffic and thinks, hey, that's a collision, and everything goes haywire. The long cable problem, on the other hand, is just a classic race against time. Let's walk through it. Station A starts sending its data. But because the cable is insanely long, it's already sent way more than 64 bytes before the signal even reaches Station B. So Station B, thinking the line is totally clear, starts sending its data. Bam! A collision happens, way down the cable near Station B. But here's the kicker. The signal from that collision now has to travel all the way back down that super long cable. By the time it finally gets to Station A has already finished sending its message and has stopped listening for collisions. It has no idea a problem ever even happened. All right, that's enough theory. We know what collisions are, we know what makes them late, and we know who the usual suspects are. Now, let's put it all together and give you that simple, actionable answer that our friend Draco was looking for all along. And boom, here it is. This is your decoder ring. If you see your collisions counter going up, it most likely just means you're looking at an old half-duplex link, and it's working exactly as it should. It's totally normal. But if you see that late collisions counter going up, even by one, that is your giant red flag. That is abnormal. You need to go find the problem and fix it. And while you're at it, keep an eye on FCS, or frame check sequence errors. They're often a side effect of the mess a duplex mismatch makes. And this is exactly what you'd be looking for in the real world, on a real piece of gear. This is a diagnostic screen from a switch or a router. You'll see a whole bunch of different counters, but the one you care about is right here, late collisions. On any healthy, modern network, that number should be 0. It should always be 0. If it's anything else, it's time to put on your detective hat. So there you have it. We've gone from a really confusing and frustrating topic and turned it into a clear, simple diagnostic tool. Let's just hammer home the absolute key points you need to walk away with. First, just remember the difference. Regular collisions, that's just the sound of an old shared network doing its thing. Late collisions, that's a serious fault. Second, know your two main culprits. It's almost always a duplex mismatch or a cable that's just too long. Third, remember the magic number. They're late because they happen after that critical 64-byte window has passed. And finally, never forget the impact. Late collisions will absolutely destroy your network's performance. And that really just leaves us with one last thought. You now know enough to go from being frustrated by a slow network to actually being able to diagnose it. So the next time things start to grind to a halt, you know exactly what the two prime suspects are. You know where to start looking,